Hey folks, today we're going to be talking about this thing called molar mass. And in order to do that, one of the first things we're going to have to do is kind of review how do we count the number of elements we have in a formula. So below here we have three formulas. We got Al2S3, Na2SO3, and Sn in parentheses SO4 in parentheses 2. So, for example, in the first problem, I can tell you that there are two aluminums and three sulfurs. What I want you guys to do is I want you to, for the second and third problem, tell me how many of each element do you have. Go ahead and take maybe 30 seconds and work on this. Pause the video if you need more time. Here we go. Okay, so this 2 here stands for the Na, so it means we have two Nas. There's no little subscript next to the S, so we just have one of those. And then O, there's three of them, so we have three O's. So it's two NAs, two sodiums, one sulfur, and three oxygens. People get tricked up on this last one though, because this 2 is kind of like you have to, factor it in. So you'll have one tin, one SN, but then you'll have two of these sulfurs because you kind of have to, factor it in there. And then instead of having four oxygens, you have four oxygens times 2, so that's a total of 8 oxygens. So yeah, this one's kind of tricky. You have one tin, two sulfurs, and 8 oxygens. This is a skill that we'll be testing you on. So make sure that you feel comfortable with this and that you get a little practice with this. But the main thing we're going to be talking about is something called molar mass. So what I want to do now is actually kind of show you these are the skills you're going to need to know by the end of the day, and then we'll get into learning how to use those skills. So we're actually going to use this example of tin sulfate, tin sulfate, SnSO4 in parentheses 2 for our next little problem. So this question asks, how much does each atom weigh? Yeah, that's kind of what we're going to have you do a little bit later. Anyways, 2 things we need you to know by the end of the day. Number 1, you'll be asked to figure out the molar mass of a compound. So in this case, we're using the compound of tin 2 sulfate. Again, we'll explain how to do this in all due time. And then the second thing is this thing called percent composition. We probably won't get to percent composition today, but we'll start with figuring out molar mass of a compound. In order to do that, you're going to need to know the molar masses of each individual atom. So again, I'll explain this more in detail, but I just kind of want to show you the steps for now. If you're wondering where I got those numbers from, the answer is from the periodic table. See, look, here they are. These are kind of like the little element cards for each element. And then what you're going to do is you're just going to say, okay, the molar mass says I have 1 of my SNs, I've got 2 of my sulfurs, and 8 of my oxygens, again, from that kind of previous problem we worked on. So then what we're going to do is just going to plug in this molar mass for each atom, which in this case is 118, 32, and 16, and then just kind of treat it like a math problem and solve it. And we end up getting, 310.85. So that would be the answer. That's kind of how we figure out the molar mass. For those of you that kind of have already got this, are like, oh, awesome, that's how you figure out molar mass. That's great. If you're like, what the heck just happened? It's okay. We're going to spend the rest of notes here today kind of explaining how to do this. The last question asks you to figure out percent composition of sulfur in SnSO4 in parentheses 2. What percent composition really is it's the sulfury part, or kind of the blue part, of this molar mass. So what we're going to do is we're actually just going to take 64 and divide it by 310. So sulfur is 64, that's the total amount of mass based on sulfur, and then the whole molar mass is 310. So we kind of divide those two numbers, multiply it by 100 to make it a percentage, and we get 20.6%. Again, if you're like, that was way too quick, that's okay. We're going to kind of spend the rest of the time explaining this in a little bit of detail. But maybe this gives you a little insight as to, hey, what we're going to do here. Okay, so again, these are kind of the 2 answers that we expect you to find by the end of the day. Let's talk about how we actually do this. Okay, so what is this thing called molar mass? Simply put, it's this decimally number that's on every element card on the periodic table. So in this case, the element card says 22.985777. That's the molar mass. which is also known as the average atomic mass. Pretty much how this works is sodium doesn't always just have, 23 protons and neutrons. Sometimes it might have, 11 protons, but then 13 neutrons. So that would be 11 plus 13 would be 24. Or sometimes it might just have 11 and 11. 11 protons and 11 neutrons, which would add up to 22. So, kind of depending on which type of atom you're dealing with, remember those are called isotopes, you'll get different atomic masses. So, a molar mass is just kind of taking all those different atomic masses, whether it's 22, 23, or 24, and kind of averaging them based on how frequently they show up. So, yeah, it might be good to remember that an isotope has the same number of protons, so they would all be sodiums, but then a different number neutrons. And then the average atomic mass is just like you take the average of all of them. Yeah, so for example, sodium has sodium 22 and sodium 23. So that would be sodium either with 11 protons and 11 neutrons for 22, or 11 protons and 12 neutrons for 23. And then, yeah, the sodium 22 is really just 1% of the time we'll see that happen. And 99% of the time, the more common one is sodium 23. So kind of if you just average those out, that's how you get this number of 22.98577, for example. So yeah, sodium 22 you can think of as like a rare version of sodium, kind of like a shiny Pokemon versus like a regular version. They're pretty much the same, except the protons are just different. Anyways, sorry, that was really nerdy to say. Okay, so this is just like an example. We won't have you actually calculate average atomic mass, but just know that you can do it. You pretty much just take the mass times the percentage, and then you just add them all up. What we want to talk about more is this thing called a mole. So a mole is a number. Specifically, it's this number, 6.022 times 10 to the 23rd. So it's like if someone says, like, I've got 50K saved in the bank account. K stands for 1,000. So that would be saying I have 50,000 saved in my bank account. Or, like a rack in rap music, rap and hip hop music is like a set amount, a set stack of like how many bills it is. I'm probably not the person to talk about this stuff. Anyways, a mole is like just a very specific number, and it's 6.022 times 10 to the 23rd. You might be wondering, why is that the number they came up with? And the answer is because science. There's this dude called Avogadro. He came up with this number, and he was like, okay, if we times everything by this number, then what happens is their weight in like protons and neutrons ends up equaling their weight in grams. So if you take 6.022 times 10 to the 23rd, which is like a huge, huge number, yeah, if you take this many atoms, like let's say cesium, for example, remember cesium's atomic mass is like 132.9 grams per mole. So if you take that many cesium atoms and you put them on a scale, it's going to weigh 132.9 grams. So this is the mass when you look at one atom. That's like the average mass in atomic mass numbers, which is just how many protons and neutrons it has. It averages out to be, 132, or we could say just 133 protons, pretty much. But then if you take this many, a mole of cesium atoms, it'll weigh 132.9 grams instead of 132.9 atomic mass units of protons or neutrons. Kind of cool how they were able to figure out that this is the number that relates them both. So yeah, it just gives us a way to convert from atoms into grams. So think about it. If you're in a lab, you're not going to be able to measure out a specific number of atoms, but you can measure out grams. So that's why they did the conversion. Okay, so mole is super important. It tells us how stuff reacts. So for example, if you take 1 mole of sodium and you react it with 1 mole of chlorine, you're going to produce 1 mole of NaCl, which is table salt. Now, if you were to take, on the other hand, if you were to take 1 gram of sodium and react it with 1 gram of chlorine, you wouldn't get 2 grams of table salts. It would look way, way different. You'd have some stuff that reacts, you'd have some stuff that didn't react, so you'd have some chlorine left over, and then you'd end up giving like less than 1 gram of table salt. So if we measure out exactly 22.99 grams of sodium and 35.45 grams of chlorine, which is chlorine's molar mass, and sodium's is, of course, 22.99, we're going to get whatever the molar mass in grams of NaCl is, kind of when you add the two of them together. So yeah, this helps us with reactions. So you'll notice that sometimes we'll pour out ridiculous numbers of each things. But what that really is it's just 1 mole of reactant A, 1 mole of reactant B, and that'll give us, I don't know, 1 mole of product C, for example. So yeah, it's just a conversion factor from mass into moles. So kind of from, grams and stuff into atoms and stuff. And yeah, the molar mass is the sum of all the masses of the atoms in the chemical formula. So what that means is if you have 1 sodium and 1 chlorine, to find the mass of NaCl, which is sodium chloride, you'd take the molar mass of Na and you'd add it to the molar mass of Cl, which would end up being, like 58.44, for example, because that's 22.99 plus 35.45. Hopefully that makes sense. I know this is a lot of numbers, so if it's scary, that's okay. We'll work through some problems in class today. And then there's kind of 2 steps. You just multiply. So multiply however many sodiums you have, and then you add that to however many other things you have. Okay, so let's take the example LiNO2. I'm actually going to give you the molar masses right here. So if you look on the periodic table, you'll find lithium's molar mass is 6.94, nitrogen's mass is 14.01, and oxygen's mass is 16. So what we're going to do is we're going to say, okay, we have one of these, and 2 of these oxygens, so we get 32. And then we're just going to add up 32 plus 14 plus 6.94, and that'll be our answer for our molar mass. So it's not very complicated in terms of the actual math that we have to do. We just take one number, add it to another number, and add it to a third number. And then you just kind of have to make sure that your numbers are right. But there is a little bit of complexity in actually kind of figuring out what these numbers are. And remember, all you have to do is look on your periodic table. So make sure you have one. Yeah, so the molar mass of LiNO2 is 52.95. Let's see. Now, another question we can ask is about percent composition, which, as I said earlier, in this case, we're asking how much nitrogen do we have in our lithium nitrite, for example. So to do that, we're just going to take the mass of nitrogen and divide that by the mass of the whole thing. So percent composition is something we'll get into a little bit later next time. But for now, guys, hopefully this makes sense. Hopefully you feel better about this, and hopefully you have a great day. Take care.